Welcome to this explainer, the infinite paradox that breaks math. Okay, suppose you write down an infinite list of every decimal number between 0 and 1. I can prove to you, literally on a single napkin, that your list is missing something. Let's just picture this. Imagine a stick figure unfurling a massive, infinitely long scroll of paper. And on this paper is a list filled with random decimal numbers, just stretching on forever and ever. I want you to really picture holding this infinite list. Think of it as a physical, incredibly heavy object. You're standing there, arms crossed, proudly looking at your scroll, and you believe with 100% certainty that your list is absolutely completely finished. You've got them all. We're looking at countable infinities versus uncountable infinities. Now, it's super easy to build false confidence when dealing with the infinite. You see, before we tackle real numbers, we have to realize that certain infinities can actually be systematically organized. We separate them into countable infinities, like whole numbers and fractions, and uncountable infinities. And that uncountable category, that is the chaotic, mysterious territory of the real numbers. So, integers, rationals, algebraic numbers, all of these are countable infinities. To understand why we feel so confident about this, just look at the integers. 1, 2, 3, obviously you can list those. But incredibly, even fractions can be listed. Back in 1891, Georg Cantor proved that if you arrange fractions in a grid, you can snake a diagonal path through them, hitting every single one. First fraction, second fraction, third, and so on. Because of this slick trick, it's completely reasonable for us to assume that real numbers, those endless decimals, well, they're going to behave the exact same way, right? Well, that brings us to the hubris, the idea that you possess the complete, infinite list of all real numbers. You stand there proudly atop the mountain with your infinite scroll. Every single row is a real number written out as an infinite decimal. You genuinely believe you have conquered infinity. You've beaten the system. Here's the method. Read row 1, digit 1, change the digit, and repeat. So imagine a second stick figure walks in holding just a simple square napkin. They're going to test your complete list with a ridiculously simple physical act. They draw a diagonal line down your infinite scroll. Then they take the very first digit of your very first number, write it on the napkin, and deliberately change it. If it's a 5, they cross it out and make it a 6. If it's anything else, they make it a 5. Second row, second digit, changed. Third row, third digit, changed. They do this forever, building a completely brand new number right there on the napkin. Which brings us to a huge question. Could this newly built number be anywhere on your supposedly complete list? We must now check this newly minted number on the napkin against your massive infinite scroll. We literally have to go row by agonizing row to see if the number we just built is anywhere on that list. The list is complete. Remember, you were absolutely certain just moments ago that your scroll contained every single number. The list was locked in, 100% complete. Now look at row 1, digit 1. Could our new number be the first number on your list? No way, because we deliberately changed the first digit to something else. It fundamentally disagrees with row 1 right out of the gate. It's a total contradiction. Could it be the second number? Nope, the second digits disagree. The third? No. How about the millionth? No, because they differ at the millionth digit. For every single row n on your list, this new number differs in at least the nth decimal place. Suddenly, your stick figure starts sweating blue water drops. The list has failed. Your precious scroll mathematically catches fire and just crumbles to ashes. It is an absolute contradiction. We didn't fail to find a list. We proved no list is possible. This quote brilliantly illustrates the monumental implication of Cantor's proof. We didn't just fail to find a clever way to list the real numbers. We proved that no list is possible. Any conceivable attempt by any mathematician using any method ever is mathematically doomed from the start. Uncountable, an infinity so massive it cannot be mapped to or listed by the counting numbers. This leaves us staring into a vast, empty mathematical void. It is an infinity so overwhelmingly large that it fundamentally cannot be mapped or listed by our standard 1, 2, 3 counting numbers. There are simply too many real numbers to ever label them all. Now this fixes the 0.999 repeating equals 1 worry, reveals an endless tower of infinities, sparks the continuum hypothesis, and was proved independent of standard axioms. Let's unpack that because this isn't just a neat party trick. Cantor knew there was a technical worry about decimals, like how 0.999 repeating mathematically equals 1, but by restricting our digit flipping to just 5s and 6s on that napkin, the proof perfectly survives. And from there, it unleashes a terrifying reality, an endless tower of larger and larger infinities. This actually sparked the continuum hypothesis, asking if there's a size in between, which later mathematicians proved is utterly independent of our standard axioms. It literally broke set theory as we knew it. So we have constructivists versus completed infinity. Unsurprisingly, not everyone loved this. There's a real, visceral discomfort some mathematicians feel about this proof. Constructivists kind of hate it because it doesn't actually produce a specific missing number, it just proves the list is flawed. Others absolutely hate the idea of treating infinity as a finished, physical scroll, rather than an ongoing process. You handed them a completed infinity and then acted surprised when it broke. And you know what? That debate is still alive and well today. Infinities hiding inside infinities. But regardless of the philosophical discomfort, the math holds. The countable rows of numbers you thought were so vast are actually just a vanishing speck inside an uncountable ocean. The diagonal argument is really just a finger pointing into the void, quietly proving that there are numbers missing everywhere. It leaves us with this incredibly humbling and mind-bending realization. What other unfathomable sizes of infinity are quietly hiding out there in the dark?